Yeah. So what we were discussing is whether there are many kinds of infinities and whether some infinite numbers are more or less than the others, or not exactly numbers, but are some infinite quantities more or less than the other. And there was some basic view what we were thinking. For example, prime numbers are much lesser than odd numbers, and odd and even numbers are lesser than the or half of the actual total natural number. So that way we were thinking that those infinities should be lesser, but actually it is not like that. And I was explaining them, and there is a better way to explain that, and we will see it today. Okay, we'll see it today. Now let us say that you had all the, we'll see it this way. Okay, and this is illustrated by what do you call it? A concept. A mathematician presented this concept in the late 1920s. David Hilbert was an English mathematician, and very nicely illustrated. Okay, actually it was found out about 100 years earlier by a German mathematician called Georg Cantor. But his style of presenting was obviously mathematical, right? I mean, in the sense that Hilbert presented it so in a way that everybody can understand. Okay, so let us call it as Hilbert's Hotel Infinite. Okay, so I'm sure all of you have stayed in hotels, but all of them are finite hotels because they have a finite number of rooms, right? Some of them might have been very big. I don't know, you might have stayed in a 500 room hotel or a 1,000 room hotel. They do exist, but all of the hotels have a finite number of rooms, right? So you can't have infinite rooms or infinite guests. Let us assume that the policy is that each guest is accommodated in a separate room, no sharing. Okay, fine. So now let us see. Okay, Ashish also joins. All right, Ashish is there. So guys, we are just continuing our last week's discussion of infinites and how to actually say whether one infinite is equal to another or more. Okay. So yeah.
So there's a video on TED Ed about something about an infinite hotel.
That's the same thing I'm explaining right now. Hilbert's.
I watched it. I watched it like a few years back.
Okay. I think Sai Pranav is much this one. Yes, Hilbert's infinite hotel. Okay, that is what we will quickly. You remember all of that, Sai Pranav?
Yes, sir. I remember most of it.
Great. So maybe you can help me with this one today. Okay. So let us say that initially only the all the hotel, as we said, hotel is infinite. Okay, and initially all the odd numbers came. So there is a guest. Okay, let us see. So a guest bus arrives, but the bus itself is infinite. Okay, and unlike normal buses which will have 40, 50, 60 seats, this bus there is no end to that bus. Okay, but all the guests in that are like the odd numbers. Okay, so 1, 3, 5, 7, 9, like this. These are the names of the guests. Okay, and they want to go and check into this hotel, Hilbert's Hotel, right? So the guy says, okay, come on, yes, you have I have rooms for all of you. There is no shortage of rooms. So let us go like this, that what are your names? Guests are 1, 3, 5, 7, 9, 11, 13, like this. These are your guest names. But he said, don't worry, I am going to accommodate you. Okay, first I'm going to accommodate you in my room numbers in hotel Hilbert rooms. Okay, 1 will go in 1, 3 will go in 2, because why to leave a room blank, right? 5 will go in the number 3, 7 will go in number 4. And if you see, the pattern is very simple, right? You take half of the guest's number, so 3 is there, then you take half of it and add half to it and you will get the room number, right? So 1, starting with 1 is the guest number, half of it is 0.5, add 0.5 to it, you get room number 1. 3, you divide by 2, you get 1.5. 1.5, you add 0.5 to it, you get 2. So the room number is 2. So like this, anybody you know what will be their room number, right? What will be their room number, right? It is very simple, right? So now how? So all the so everybody in that infinite bus gets accommodated, right? You think anybody will be left without any room? No, right? Because just as the guests are infinite, the hotel is also infinite. So everybody, and you just find out which room you go. You just divide the guest number by 2, add half to it, and whatever comes, that is the room number, right? So far so good. All right. So now, but is the hotel full or not full? It's an interesting question. Huh?
Like not full.
It's not full. Yeah, it looks like. Let us see whether it can accommodate some more people. Okay, but we already know rooms are infinite. The guests of odd numbered name with names as odd numbers, they are also infinite. All of them have been accommodated. But now let us see another infinite bus comes in. Okay, this time the guests are numbered as 2, 4, 6, 8, 10, 12, 14, and so on. These are all, they are numbered, their names are like even numbers. Okay, their names are like even numbers. Okay, so what do the hotel guy says, okay, do you have room for me? He says, why not? I have room for you. No problem. Mine is an infinite hotel. But where does he place them? Right? Because 1, 2, 3, 4, 5, 6, 7, the rooms are all occupied. So hotel guy says, don't worry, I will ask my guests. Yeah, there is a thing that guests have to move sometimes the rooms. It does happen sometimes, though you don't like it, but it does happen, right? Sometimes because of booking this, that, etc. One room you have got for one day, and next day you have to get into another room. So that's what happens. He says, okay, I had applied this logic earlier because I did not want to keep these blanks, but now I'm saying the odd number, the guests which are there earlier, I says, okay, don't worry, you come out of your rooms and then simply walk into the room which is your own number. So guest number 1 will go into room number 1, guest number 3 will go into room number 3, guest number 5 will go into room number 5. He says, don't worry, everybody comes out and then goes into the rooms which are of their own name. Okay, so what happens? Automatically the vacancies get created 2, 4, 6, 8, etc. because the first set of guests were only odd numbers. So now once they get into their own rooms, the even number room, then he says, okay, you guys, the even numbered guests, come in. You also get into the rooms which is exactly as per your name. So 2 will go into 2, 4 will go into 4, 6 will go into 6, like this. So he says, so 1, 1, 2, 2, 3, 3, right? Like this, all of them are accommodated again, right? So everybody is accommodated, nobody is left, right? So no problem, everybody is okay. Now what happens? Now one more guy runs in, one more guest walks in. Okay, single guest. He says, I am the most important guy. Why do you think he will be the most important guest? You can guess. Because he says, my name is 0. 0 is the most important number. Without it, it is nothing. So he says, do you have a place for me? Now you look at the hotel, rooms are now all numbered 1, 2, 3, 4, 5, 6, 7, 8 onwards. There is no room number 0. And all the guests are occupying all the rooms with each of their names. So where do you adjust this guest number 0, right? So the hotel guy says, don't worry, mine is an infinite hotel. I can accommodate all of this. He says, okay, all the previous guests, you come out and you just shift one place to the right. So number 1 guest will go into number 2 room. Number 2 guest will go into number 3 room. Number 3 guest will go into number 4 room. And naturally, the first room will get empty. So I will put guest, our most important guest number 0 into the room number 1. And again, everybody has got all their rooms. Nobody is left without a room, right? So he says, now it is like 0 is into 1, 1 is into 2, 2 is into 3. So like this, it goes on, etc. Right? So this just shows that the number of so actually the infinitude of the odd number is same as the infinitude of the even number, which is the same as the infiniteness of the natural number. And even if you add a 0 to it, which makes the whole numbers, even then all the infinities are equal, because nobody is having any problem with any room. Everybody is occupied, right? But now comes another bus comes. Another infinite bus comes. So this time, what are the guest names? Can you guess?
Negative.
Yeah. So there is again an infinite number of guests. They are -1, -2, -3, -4, -5, and how many? Infinite number of guests, because the bus is also infinite. Now they come to the hotel. The hotel guy says, oh God, now how do I accumulate another infinite number of guests in my hotel? Right? Is there a way to accommodate them?
Yes, sir.
How?
So you can just ask that, for example, like all these guests move to prime numbered rooms, and all the people in prime numbered rooms can go to the last person's room at the end of the infinity.
Yeah, but actually, something similar, but you can do a slightly simpler, because you want to make your guests do as little work as possible. So what does the hotel guy say? Okay, all the existing guests, please come out. Okay, everybody comes out. Then he says, okay, a very simple thing. Whatever is your name, right? 0, you were there in room number 1. 1, you were there in room number 2. 2, you were there in room number 3, right? So like this, it was there, right? Okay. Now he says, okay, you just go into each one of you, you double your name, whatever, right? You double your name and go into that room. So 0 will go into which room now? Existing guests. 0 will go into room number
0.
0 will go into 0.
But sir, is there a room number 0?
So 0. So that is why. So he says, okay, because there is no room number 0, so you double it and add 1 to it. Okay, that is the formula he gives to each guest. So 0 will go into room number 2 times 0 plus 1 is 1. He goes back into it. 1 will go into
2.
2 into 1 plus 1 is 3. 1 will go into room number 3. 2 will go into room number 5. Right? 3 will go into room number 7. 2 into 3 plus 1. 3 goes into 7. Okay. So like this, now all the guests, earlier guests,
all the odd numbers.
So now they have occupied, so 1, 3, 5, 7, and then there are even numbered rooms have become free now, right? Okay, everybody has still got a room. Only thing is that they have shifted further down, and there are even numbered rooms have become vacant. Okay, so what does he do now? So he asks all the negative guys, okay, here is what you have to do. Okay, you have to take your name, multiply it by -2, and whatever room number you get into that. Okay, because this is all existing. The new guys, -1 goes into where? -1 will go into multiplied by -2. Where will -1 into -2? +2. Exactly. It goes wherever it was vacant. 2, right? Where does the -2 guy go? He goes into room number 4. Where does the -3 guy go? 6. So all the rooms which were become vacant now get occupied by the negative numbered guests. Again, is there anybody who will be left without a room?
No.
No, right? Everybody is occupied, right? So far our hotel clerk has accommodated first the infinites of odd numbers, then infinites of even numbers. Then he added one more guest with the 0. Now he added infinites of negative integers. All of them accumulated, right? So what does this mean? This means that our earlier notion that the integers are double the number of natural numbers in terms of infinity, that is also actually not correct mathematically. Okay, mathematically you say the infinities are, sorry,
everything is infinite and there is no such that these numbers are less than the others, or
yes. So all these infinity, see, it still doesn't mean that all infinities are equal. Okay, it just means that these infinities that we talked about, and initially we thought that they are different, but actually they are not. And how we say that is whether each one of them can be accommodated into another or not. If one thing can be accommodated exactly into another without overflowing, then they are equal. Okay, so otherwise they're not. Otherwise one is smaller. Now, not only this, now next comes a very, very interesting thing. Sai Pranav, you remember what comes next?
So I think next was an infinite number of buses, each carrying an infinite number of people, arrive.
Yes. So till now only one bus was arriving. Okay. And he was accommodating them. Now there is more work for him. So I'm going to clear it. So now an infinite number of buses arrive. Each bus carrying infinite number of people, guests. Okay. How are the guests named? We have to name them properly, right? So already I've cleared the previous one. Now the bus 1 comes. Okay. Bus, I will just call them B1G because bus 1 guests. Okay. Actually, there is no bus 1 because they say that, okay, these people have already come in. So bus 2. Okay, we'll name it as bus 2 because that is what is the board there on the bus. It is called as bus 2 guests. And what are their things? Okay. So their names are 1 by 2, 2 by 2, 3 by 2, 4 by 2, 5 by 2, 6 by 2, 7 by 2, 8 by 2. These are the names of the guests. Okay. Similarly, bus 3 guests. How will they be named? Do you think?
1 by 3, 2 by 3.
1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3, 6 by 3, 7 by 3. Don't see, these are just the names. Okay. So don't consider that, oh, this is the same guest as 6 by 2 is 3 and oh, same guest I have there. No, don't worry. Each one of them they were having names and we were putting them, whatever it is. These are their names. We can use this to create a formula for things, but they are distinct guests. Okay, they are different guests. So 8 by 3 like this. So similarly, B4G will have everything divided by 4. B5G will have everything divided by 5. And like this,
What
like
does,
this. Yeah.
question.
Yeah.
What does G stand for? I don't know.
B is bus.
No, I meant G.
Oh, G is guests, Sanjay. Guests. These are all guests trying to get into the hotel, right? So B9G will be 1 by 9, 2 by 9, 3 by 9, 4 by 9. Again, each one of them is infinite because though the denominator is same, the numerator can keep increasing, right? So there are infinite number of guests in each bus. So like this. And now all of them want to get accommodated. Is there place now for them in this infinite hotel? Right? Can you
So we can, for the BG2, we can tell all the guests to multiply their room by 2, and then after everyone's in their room, for BG3, we can tell them to multiply it by 3. Then by
so
4.
let us go. I think interesting idea. But first I will put what are the existing guests. We will put that existing guests. Okay, we can easily name them because they are there in the rooms as 1 by 1, 2 by 1, 3 by 1, just to make it look same. Because they have occupied all the rooms from 1 to infinity, right? And we'll call them as 1 by 1, 2 by 1, 3 by 1, 4 by 1, 5 by 1, 6 by 1, so that it is easy. Okay. Yeah. So now you were saying something. Yes, please go ahead. I think. How to do that? I think you are having an idea.
So I was saying, like, we can multiply their room numbers first by 2 and then again by 3. See, first we'll multiply it by 2, so then people go into the rooms. Then we'll multiply it by 3, then more people go into the rooms, and keep doing that.
Yes, you can do it. But if you wanted to do it in one shot, right? Because see, now you will have to do these infinite things, right? So what is this one? What do you call? So how to do that in one shot? There is an interesting way. I'll just what do you call? Show it. How do I show it? Because yes, I mean you are right. That is one approach. But to do that, all of that in a single way you have to do it. Then what you do is that because each one of them, because you will not go into the third row unless the second row is finished, and second row itself is infinite. So you will give them a formula. But the moment you give them, yes, you can ask them again to come out, again multiply something and go. That is exactly, essentially, that is what it is. But there is another way to look at it is, okay, so first you go in diagonals, you go in slanting diagonals, like chessboard, right? Chessboard. Can you imagine the A8 square on the chessboard? Okay, can you imagine, all of you? I think huh?
Yes.
Right, A8, it is a light square, right? It is a light square. Okay, A8. So now the next diagonal, can you imagine the next diagonal, which is A7 to B8?
That will be black.
That will be dark square diagonal. Then there is the next diagonal, A6, B7, C8. That is a light square diagonal, right? But can you imagine the like this dot, then diagonal, then another bigger diagonal, bigger diagonal, bigger diagonal, bigger diagonal. In chessboard, because it is limited in size, the maximum diagonal you will hit is A1 to H8, which is 8 squares, and then again you will start reducing. Okay, but if the chessboard was not limited by 8 by 8, then you would have got even bigger diagonals all the way, right? I mean, we don't in chessboard we A1 to H8, but if not, then A0 to, you would have gone to not H9, you would have gone to H8, so it would have been A B C D E H G H I9, it would have gone to A0 to I9, and A-1 to J10 it would have gone. So like this, it would have gone, right? So you just have to imagine like that, and you have to put the guess like that. So take this one, put him in room number 1. Okay. Then take this guest, then go for this guest. Okay. Then go for ask this guy to go into. Yeah. Hello.
Yes, I didn't understand.
Yeah. No, what I say is that, so you first ask this guest to go into room number 1. Okay.
Yeah.
Then now you go diagonally. So you take the second guest from this one and ask him to go into room number 2. Okay. Then you go diagonally up. This guest, you ask him to get into room number 3. Okay.
Oh, okay. And then 1 by 3.
Then you ask this guest to go into the next room, this guest to go into the next room, and then this guest to go into the next room. And then you go this guest, here I have not put. So this guest, then you ask this guest to get into the next room. Then you ask this guest go into the next room, and then this guest go into the next room. So like this, you can cover all. You keep doing this diagonally. Okay. Every guest, there is a certain point will come when his turn will come in across all these infinite rows. Okay. Even if like you don't have to wait for all the previous ones to finish. Like even in the B9G, you know that this guy's some turn within a finite time it will come when his turn will come. Okay. So, and like this, all of them will get accommodated into all the infinite rooms, and still there is nobody is left without any room. Okay. So now what we are discussing here, these are rational numbers. Rational numbers are nothing but ratios. Why they are called rational? Because they are ratios. And what is a ratio? It is something by something, right? It is 2 by 5 or it is 3 by 4. These are all ratios. What is a ratio? Ratio is a division of one number by another number. Okay, so you get, typically you use it for smaller than 1, but of course you can do it for anything in between also, like 3 by 2. Yeah, because earlier your numbers were only having like 2, 3, etc., nothing in between. But 3 by 2 or 5 by 2 gives you something in between also, right? How many are there? Infinitely, what do you call? Infinitely more rational numbers exist. Between 1 and 2, there is 1 by 2. There is also 1 by 3. There is also 1 by 4. There is 1 by 5 also, right? Between 1 and 2, there are infinite number of numbers, rational numbers in between. Okay,
Yes.
right? Actually, it is goes even more things to understand. At least all the whole numbers, integers, etc., right? They were all countable. Okay, because you always knew what is the next one, and there was never any doubt. Okay, and there was a very clear one. There was you are always clear what is the next number. So after 2, there is 3 only, right? There cannot be any number other than 3 if you are talking about natural numbers or even integers. After -2, there is -3. There is nothing else, right? Integers it is. That's why. -3, after that it is -4. So everything was very clear. Order was very clear, and you could not miss anything in between. Okay. But when you come to rational numbers, they are not countable, because you don't, okay, in terms of rational numbers, now that we define, they are ratios of numbers, right? Including 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, etc. These are all ratios of numbers. Now, can you, and you know what is 1 by 2? 1 by 2 is 0.5. What is 1 by 3? 0.33. I mean, 3, it will continue, right? What is 1 by 4? It is 0.25, right? Right? 0.25, right? Now, in case of the rational numbers, you can never say exactly which one will come next, because there may be any time when you say, Acha, this is the one that is there. No, there can be another one. If you say after 1 by 81, it will be 1 by 82. No, actually between whatever, I mean, between any two numbers, there will be one, any more number will be there. And it can be infinitely more numbers can be there in between. Right? See, between 1 by 2 and 1 by 3. Okay. 1 by 2 is 0.5. 1 by 3 is 0.33. 0.33, right? Now if you say 2 by 5, 2 by 5 is exactly not exactly, somewhere between 1 by 3 and 1 by 2. 1 by 2 is 0.5, 2 by 5 is 0.4. Right? Now, so which is closer? But if you go between 2 by 5 and 1 by 2, there is some other number is there in between also. And there is no end to it. Okay, so this is a completely different magnitude of infinity, but even this is considered as same at an infinite. When you deal with infinities, even this is considered as the same infinity as the natural numbers, because we saw by this Hilbert's infinite hotel analogy, that all of these could still be accommodated in that one hotel where we started with the infinite rooms. And hence, even this infinity is also of the same nature. These rational numbers are also considered as same. There is only thing that you cannot accommodate in this hotel are the numbers like irrational numbers. And what are irrational numbers? I think I will have to come to for it in the next lecture. I think we'll have to do it. But square root of 2, square root of 3, square root of any number which is not a perfect integer by itself. Right? Square root of 4, no problem. It is 2. Square root of 5, yeah, it is an irrational number. Why it is irrational? It cannot be written down as a ratio of any two integers. Square root of 4, you can write it. Square root of 4 is 2, and you can always write it as simply as 2. Or you can write it as 4 by 2, or you can write it as 6 by 3, or whatever way, 8 by 4. Anything you can write down as, and it is the value is same. But square root of 2, there is no way to express it other than with the sign square root, because you try to get any ratio of any two numbers. You can come close to it, but you can never exactly get the value of root 2. I think this requires some more discussion. We'll do it next week. But so far, these infinites you have understood, right? All of these infinities till now, what we discussed, they are actually of the same quantity when you deal with infinites. But there are bigger infinities than this. So maybe we will not get into all of those, but I think it is just important to know that there is a lot of fun with infinities, and there are some puzzles with infinities. I will try to find some puzzles related to infinities, and then we'll apply these principles. Okay. All right. Any questions?
Also.
Okay, I will send the link for that Hilbert Hotel and similar videos. I think TED is also there. It is also there on YouTube, number file or thing, etc. I think you can just check it out. Okay. All right then. See you next week.